What if I told you that the beautiful red planet you see in NASA photographs is actually a perfectly designed death trap? While we romanticize Mars with dreams of colonization, the reality is far more terrifying than most people realize. Like a Venus flytrap with its alluring colors, Mars conceals its deadly nature behind rusty landscapes. The harsh Martian environment makes Antarctica seem hospitable in comparison, with radiation that damages the brain and massive dust storms that block the sun for weeks. This deceptive crimson world holds countless hazards for unwary explorers. In the next few minutes, I'll reveal what lethal surprises await humanity's first visitors. What deadly secrets lie beneath that seemingly serene red surface? Have you ever wondered how something so visually stunning could be so lethal? Mars presents us with a paradox of beauty and danger. From our telescopes and rover images, the red planet reveals itself as eerily familiar. With 24.5-hour days, polar ice caps that expand and contract with the seasons, and a landscape carved with valleys and mountains that wouldn't look entirely out of place in parts of Earth's desert regions. The similarities continue, with Martian summer afternoons reaching a comfortable 70 degrees Fahrenheit in equatorial regions. You might look at these conditions and think, this doesn't sound so bad. Maybe we could adapt to life there. And that's exactly what makes Mars so dangerous. This false sense of familiarity that masks its true nature. Mars wears the mask of a serene planet while hiding the heart of a silent assassin. The thin, wispy atmosphere visible in rover photos isn't just aesthetically different from Earth's, it's fundamentally incompatible with human life. While our atmosphere wraps Earth in a protective blanket, Mars offers a mere veil. Composed of 95% carbon dioxide, the atmospheric composition is actually the lesser problem. The pressure is what would actually kill you first. At merely 0.6% of Earth's atmospheric pressure, the Martian environment would cause your bodily fluids to boil instantaneously. When transported to the Martian surface without protection, your body would experience catastrophic failure. Your eyes, lungs, and exposed skin would undergo ebulism, the spontaneous conversion of bodily fluids to steam. Death would follow in under a minute, a horrifying transformation no human has experienced. This minimal atmosphere creates extreme temperature swings. That pleasant 70-degree daytime reading plummets to negative 100 degrees Fahrenheit at night. Fluctuations of over 100 degrees in a single day that would devastate most Earth technology through repeated expansion and contraction. The very terrain that appears so familiar harbors additional dangers. The characteristic red dust consists of sharp-edged particles that have never experienced Earth's weathering processes. These jagged particulates contain perchlorates, compounds toxic to humans. Mars tricks us through its visual familiarity. We see mountains and valleys that resemble Earth, but can't see the invisible dangers. The insufficient atmospheric pressure, the radiation penetrating that thin air, or the toxic composition of the soil. The planet presents itself as a frontier to be conquered, when in reality it's a carefully laid trap of misleading similarities and hidden dangers. Those invisible dangers we mentioned aren't just a figure of speech, they're literal death sentences, silently penetrating every cell in your body. While Earth's powerful magnetic field deflects most harmful radiation, Mars offers no such protection, leaving astronauts exposed to cosmic bombardment that would gradually destroy their DNA and electronics alike. Earth generates a powerful global magnetic field extending far into space, creating a protective bubble that shields us from high-energy particles emitted by the sun and distant cosmic sources. Mars lost this critical defense billions of years ago. Living on Mars would be comparable to residing in a nuclear exclusion zone, where the dosimeter never stops ticking, except worse. Every day on the Martian surface adds another layer of exposure, similar to receiving multiple CT scans daily without the benefit of a lead vest. The radiation environment on Mars is devastating. The cumulative exposure an astronaut would receive far exceeds safety thresholds established for nuclear workers and ISS astronauts. Imagine your cell's repair mechanisms gradually faltering as radiation damage accumulates, like a building whose structural integrity weakens with each passing storm. Medical studies demonstrate this cellular degradation leads to accelerated aging, increased cancer risk, and potentially irreversible damage to the central nervous system, affecting the very cognitive functions crucial for survival decisions. The same particles that damage human tissue also corrupt the electronic systems essential for life support. Engineers call these single event upsets, radiation-induced glitches that can cascade into catastrophic failures. On Earth, a system reboot solves many problems. On Mars, when your oxygen generator glitches during a radiation spike, the consequences could be fatal. Mars presents another invisible threat, its dust. Unlike Earth's weathered particles, Martian dust consists of microscopic, electrostatically charged daggers containing potentially toxic compounds. This dust infiltrates equipment much like asbestos penetrates lungs, silently, persistently, and with devastating long-term effects. It clogs air filters, degrades solar panels, and could trigger inflammatory responses if inhaled. During Mars's global dust storms, which can last months, these conditions amplify dramatically. As dust blankets solar panels and atmospheric density shifts, power generation falters precisely when you need it most. The storm traps you indoors while radiation continues its relentless assault on your shelter, your equipment, and your body. These invisible threats create a dangerous feedback loop. As radiation compromises your health and decision-making ability, dust simultaneously degrades your life support systems, creating a spiral of compounding problems that become increasingly difficult to manage the longer you stay on the red planet. If Mars's radiation and dust storms weren't intimidating enough, there's a more immediate concern: actually surviving the journey and landing. Since 1960, humans have launched 52 missions to Mars, orbiters, landers, and rovers, yet only 23 have succeeded. That's a stunning 56% failure rate that has earned Mars an infamous reputation among space agencies as the spacecraft killer. This statistical evidence, representing billions of dollars and thousands of careers invested into attempts that often end in seconds, reveals how Mars seems to actively resist our presence. Some scientists blame these failures on the Great Galactic Ghoul, a cosmic phantom with an appetite for expensive spacecraft. While obviously not literal, this nickname reveals something important. Even the most rational minds in aerospace feel there's something uniquely hostile about Mars. That defies our technological capabilities. The technical reality is even more unsettling. Mars presents what engineers describe as the worst possible landing conditions imaginable. Its atmosphere exists in a frustrating middle ground, too thin to provide meaningful resistance for slowing down spacecraft, yet too thick to ignore during entry calculations. This too thin yet too thick atmosphere creates a unique challenge that doesn't exist on airless bodies like the Moon or dense atmosphere planets like Venus. What makes landing particularly terrifying is what NASA engineers call the 7 minutes of terror. The critical phase when a spacecraft must transform from an interplanetary vessel traveling at over 12,000 miles per hour to a stationary lander, all completely autonomously due to communication delays with Earth. The European Space Agency's Schiaparelli lander illustrates these challenges perfectly. In 2016, after a journey of 308 million miles, its engines cut off prematurely, just moments from touchdown. The lander slammed into the Martian surface at nearly 200 miles per hour, instantly becoming scattered debris. The failure was traced to a simple sensor glitch that incorrectly reported the spacecraft had landed when it was still airborne. Engineers have tried various solutions: parachutes, heat shields, retro rockets, sky cranes, and giant airbags. But each must be precisely calibrated to Mars conditions. The United States has developed surprising proficiency, successfully landing 18 out of 23 attempts at 78%, while remaining the only country to achieve landings on the planet. Even highly capable space agencies like Russia, Europe, and China have struggled despite significant technological prowess. These failures reveal the extraordinary engineering required for even basic robotic survival on Mars, which raises serious questions about our ability to support human life there. Beyond the technological hurdles of reaching Mars lies a deeper, more insidious threat that can't be solved with better engineering. When machinery fails in space, replacement parts can be sent, but when the human mind fractures under extreme isolation, no engineering solution exists. While machines can be designed to withstand Mars' hostile environment, the human mind remains our mission's most vulnerable component, a fragile system facing unprecedented challenges in the void between worlds. The isolation of Mars exploration represents an entirely new frontier of human experience. Earth environments offer nothing truly comparable. ISS astronauts can see home through their window with real-time communication, while Antarctic researchers know evacuation remains possible. Mars offers no such comfort. Picture this scenario: an astronaut experiences chest pains during a Martian dust storm. They send an urgent message to medical staff on Earth, but must wait 20 minutes for the signal to arrive, then another 20 for initial instructions to return. In those 40 minutes, they must diagnose and treat themselves while wondering if today marks their final hours, millions of miles from any medical facility. This communication delay transforms every interaction. Messages become monologues rather than conversations, creating a psychological disconnection more profound than physical distance. Even submarine crews, isolated for months underwater, maintain instantaneous communication with command and operate knowing extraction protocols exist. Mars explorers face a minimum 2 to 3 year commitment with no early return option, as spacecraft can only launch during specific planetary alignments occurring roughly every 26 months. The confined habitat, roughly the size of a small apartment, shared with 3 to 5 people for over 1,000 days, intensifies these challenges. Minor annoyances compound into significant tensions when privacy becomes nearly non-existent. Living under constant survival pressure creates a perpetual state of alertness. The environment actively threatens survival. Equipment failures could prove fatal, and medical emergencies occur beyond specialized care. This unrelenting stress alters decision-making, emotional regulation, and physical health in ways we've only begun to understand. The psychological weight extends beyond personal survival. These explorers will carry the burden of representing humanity's multi-planetary ambitions, knowing their actions, decisions, and potential failures will be scrutinized by billions. Perhaps most profound is how Earth itself, with its open spaces, abundant water, and changing seasons, becomes an increasingly abstract memory, replaced by the monotonous red landscape that intensifies the fundamental disconnection from our evolutionary home. Despite all of these dangers, experts who've spent careers studying Mars remain cautiously optimistic about our future there. The challenges aren't insurmountable, they're just engineering problems waiting for solutions. After years of research and failed attempts, specialists like Pascal Lee from the CD Institute explain, on Mars, we'll need to create infrastructure to solve the problems our planet handles automatically. This perspective frames Mars not as impossible, but as humanity's greatest test. The technological foundation for Mars missions is already forming through integrated approaches. NASA's plans to use Martian regolith for shelter, while SpaceX develops Starship-based habitats, represent our first steps towards sustainable presence. Yet Mars will never yield easily. Stephen Petranek notes that terraforming will be incredibly expensive, and it may take 1,000 years before humans can walk the surface of Mars, in an environment not unlike what one finds along the west coast of Canada. This 1,000-year timeline reveals the true nature of our challenge. Can humanity transform a hostile world into a new home among the stars? The answer may define our species' legacy. So it beckons the question, would you ever go to Mars? Comment down below and tell me why or why not. Thanks for watching, and don't forget to like and subscribe.